Okay. Sure hope it saved that first part. Technology. So, yeah, somebody asked if I'm going to be uploading this to Canvas, and I will. I'll put it with the, where I put the recording, so you'll see it in the Exam 1 module. So just in case you guys were wondering. Okay, and it looks like some of you have come up with an answer here. I know on this one, sometimes people are like, oh no, I've got fractions that I'm dealing with, right? And, and remember, if you haven't made fractions your friend, then you might want to, have more practice with them, find a calculator that works with fractions. That can always be beneficial for you too if that's been a stumbling point for you. All right, so I know the point and I know that my perpendicular slope, so let me write that over here. All right, so this is the symbol in math for perpendicular. Perpendicular slope is -5/3. All right, so that's what you want to use when you're putting it into either the point slope form or the y equals mx plus b form. All right, so if I do this, I've got y minus a -7, right? And then equals m, which in this one is -5/3, times x minus a -4. All right, well, minusing a negative is really adding, right? So I'm going to change these here. So I end up with y plus 7 equals -5/3 x. All right, I'm distributing this through. And then I've got -5/3 x, I'll put it over here, all right, times 4. All right, which is like 4/1. When I'm multiplying fractions, I just go across the top and across the bottom, right? So, so I really have here minus 20/3. But now I need to subtract my 7 over, right? But I need to make 7/1 into a fraction where I have 3 as the denominator because I've got to be able to add these fractions together. So I need this to be something over 3, right? So if I change this denominator to 3 by multiplying by 3, then I need to multiply the top by 3. So 21/3 is what I'm really subtracting over there. So 7 is the same thing as 21/3. Okay, so I'm going to end up subtracting that 21/3 from both sides. And then I get y equals -5/3 x. And be careful on this, right? It is, and we are adding 2 negatives there together, so it is going to be -41/3 for that y-intercept.
But I think we have to subtract 7 from both sides.
We did. Right? So 7 is the same thing as 21/3. So I subtracted the 21/3 from both sides.
Right, yeah.
Okay. Is that clear?
So I think there's a mistake. It's supposed to be a +20.
No, because I've got a -5 times a +4.
Oh, negative. Oh, okay.
Right? Does everybody see that? These are good questions. Right? Sometimes like those negatives are going to be the thing that sometimes are, are tricky, definitely on the exam. So watch those carefully. Yeah. All right. Other questions? Those are great questions that you guys have when you were working through it, just to make sure you see how to get there. Okay, how are you guys feeling so far? Give me a thumbs up or a, I don't know, a little...
I'm good.
Yeah? Feeling good so far with it? Okay. All right, so now we're going to move on and talk about the elimination and substitution method, so solving systems of equations. And remember, you're using those when you're doing that car comparison project. And if you still have questions about that, feel free to stay on after this, and I can, help you with that, or reach out to me with questions, Canvas inbox, because I want to make sure that you're feeling confident in what you're doing to turn that project in. Okay, so the first one is saying use the substitution method. How do I use the substitution method to solve this? Can somebody tell me?
Yeah, we can substitute x equal to y minus 1 in the x value for the first equation.
Yeah, right. Does everybody see that? We're going
And
to put
solve for y.
Yeah, so let's go ahead and do that. So I've got 3y plus, and instead of x, I'm going to put this because x equals all of that. So 2y minus 1, and then equals 4. And then notice now I only have y values to solve for, right? And that's why I have to do this. So I just have one value to solve for. So add those together, I get 5y minus 1 equals 4. Let's add the 1 over. 5y equals 5, so y equals 1. Am I done?
So suppose I put the parentheses, so I substitute the second equation and the first equation. Do I need to do the parentheses? Or I know it doesn't change the meaning of
yeah, if you put that in parentheses there, it's not going to change anything because this is a plus sign there. If that was a minus, then you'd have to distribute the negative through to both of them. But yeah, on this one, since that's a plus, it's not going to change the meaning of it. But that's a good question, just to be careful with that. Okay, so am I done? Is that all I have to do? Okay, some of you are shaking your head no, right? We're trying to find the point in which these two lines are intersecting each other, and I found the y value as 1, but I still need to find that x value. Okay, and the reason why I asked you, are we done here, is because, again, that's probably the most common place. If people miss this, it's because they forget to find that x value. Okay, so I want to make sure that you're doing that. All right, so how do we do that? How do we use this y equals 1 to figure out what x is now?
Substitute the next equation.
So we'll go, so I'm going to use this equation right here, like you said. So x equals 2 times y, which we know to be 1 now, and then minus 1. So x equals 2 minus 1. So x equals 1 on this one. So our ordered pair, our point in which these two lines cross each other, that solution is that point 1 comma negative 1, or sorry, 1 comma 1. They're both 1s on that one. Okay, questions on that? Okay, so this one is the elimination method now. So notice the difference between these, right? Do you notice that this is, one of the variables is by itself, and so that's easiest to do the substitution method, where both of these are written in that standard form. All right, the two values, our two variables, are on the same side of the equation, and then our whole numbers are on the other side of the equation. Okay, let's see here just a second. Okay. All right, so on this one with the elimination, we were trying to add the two equations together so that one of them eliminates. All right, and right now, if I add them together how they are, I'm not going to get one of them to eliminate, but I can make one of the variables eliminate. All right, so say that I'm looking at eliminating the s's. All right, well, one way, and probably the easiest way for most people to remember this, to do it, is that we need to make these numbers opposite each other. So I've got an 8s and I've got a 6s. So if I multiply this top equation by 6, or negative 6, so we can make it into its opposite, and then multiply the bottom equation by 8, right? So I'm kind of like, just choosing the opposite number there. There's other ways you can do it, but this is probably the easiest way to make those eliminate. And then I'm distributing that -6 through to the whole thing. All right, so if I distribute that -6 through, I get -48s, and then minus 72t, and then equals -96, right? So -6 times 16 is -96. All right, now let's do the same thing on the bottom. Let's distribute that through. That's going to give me positive 48s, all right? And then I'm going to have plus 72t equals 96. All right, so this one, something kind of weird happens on it, and you should have had some of these on your, homework and stuff. What happens here now when I'm trying to add these together?
You have to do the 72, -72 and plus 72, cross it out.
Yeah, so
Cancel
this,
it out.
this goes to 0, this goes
they're
to
all
0. Yeah. And so we're trying to think here, right? Is that a true statement? Does 0 equal 0?
Yeah, it's a true statement.
The truth.
Yeah. So since it's a true statement, that's not our answer, right? And 0 is not our answer. What is our answer then if it's a true statement?
Infinite number of solution.
Yeah, infinite solutions. All right. And if it was, say that it was like a false statement, say that we ended up with like 0 equals 3 or something like that, right? If it was a false statement, then that would tell us that it's a no solution, all right? So make sure you know the difference between those two, because I'll just tell you right now, usually one or the other is going to show up on the exam, right? Where you need to know the difference between it. So it's just, is it a true statement or is it a false statement? That's telling you whether it's infinite solutions or no solutions. Okay, or all real numbers is another way you can say infinite solutions. Okay, questions on that? Okay, let's get to some, got some story problems here, right? And sometimes those story problems, people are like, how do I do this? Okay, so let's focus on a couple of them here to make sure that you know how to do these. Okay, so Deep Thought granola is 25% nuts and dried fruit, right? So it's both of those together. And Oat Dream is 10% nuts and dried fruit. How much of each, how much Deep Thought and how much Oat Dream should be mixed to form a 20-pound batch of granola that is 19% nuts and dried fruit? Okay, so when I set this up, I think to myself, I like to make a little chart. You don't have to make a chart, but I think it makes it a little bit easier to keep things organized and to figure out what's what on this, okay? So down the side here, I'm thinking about like how I know what I'm going to put here is I'm looking at the labels in my, in my story problem here. So I can see I have pounds, so that's going to be one of the things that I'm going to be dealing with, okay? And then I'm going to have percent is the other one, because I can see that these are both dealing with percent. Okay, and on this line, I'll tell you like that's changing from a percent to a decimal. And then this last is the total. Okay, and then along the top, I'm thinking, what are the two things that I'm mixing together? All right, well, I'm mixing the Deep Thought with the Oat Dream, but specifically, right, so I'm going to put this here. So DT, I'm going to say is Deep Thought, and that's 25% of the nuts and dried fruit. And then the Oat Dream, so OD, right, is 19%. Oh, sorry. is 10%. I looked at the wrong thing there, right? Just gonna see that. Oop. Right, it's right here, 10%. But we want a total that is the 19%. Okay, so does everybody see like how I'm kind of going about setting it up? Because that usually is probably the trickiest part. And like I said, you don't have to use the table. Like if you can, figure this out another way, write these equations without it, I'm totally fine with that. You do not have to write it, but it's just a good way to do this, okay? So I need to assign variables though. I need to say what's what in here. So I'm saying my deep thought, one, I'm going to call X, all right? And then my oat dream, I'm going to call Y. And you can use whatever variables you want, but those are the ones I'm choosing to use. Okay, so I don't know how much deep thought and oat dream I'm mixing together. So that I'm just going to put, I don't know how many pounds of deep thought, and I'm calling that X. I don't know how many pounds of oat dream, so I'm going to call that Y. And then the total, right, of this is 20 pounds, right? Notice that this is dealing with pounds on here, right? 20 pounds. So 20 is the total amount of pounds. So I'm not using that 19% yet, right? I didn't use any of these percentages yet. Okay, but then on the second line, this is where I'm changing my percent to a decimal. So how do I change 25% to a decimal?
Divide by 100.
Which would give us
0.25.
0.25, yep. And how about 10% to a decimal?
0.1.
Yep, 0.1. If you put it as 0.10, that's fine. You don't need the 0, but 0.1. And then 19% to a decimal, 0.19, right? And now to find, so this top line here is my first equation. I want to make sure that's clear. So I have X plus Y equals 20. That is one of my equations. And then this bottom line where the total is going to be my second equation. And how do I get that? Well, I'm going to multiply these things together, right? So 0.25x, multiply these guys together, 0.1y, and then multiply those together. It kind of looks weird there. What is 0.19 times 20? $3.8, right? Okay, and so that's what I get then for my second equation. 0.25x plus 0.1y equals 3.8. And now you can use the substitution or elimination method to solve this. And I don't care which way you do it, right? Whichever way looks easier to you is what I want you to use on that. Okay, so why don't you just take a minute and see if you can figure this out on it. I'm going to use the substitution method on it, but it doesn't matter which way you decide to do this, okay?
So, question.
Yeah.
Why we have to multiply 20 by 90%? Why just we said 25x plus y equal 0.19?
Because we have to, because it's 19% of the 20 pounds. So you notice like how you were multiplying these two together to get this number and these two together to get this number. Well, if you're only given the number of pounds and the percentage, we've got to multiply those together to get how many pounds of it equals out to be 19%.
Okay, so every time when we make a table, we make sure to multiply, right?
You multiply those if they give you both of those.
Yeah.
Sometimes they'll give you this total amount, and so there's no multiplication that you'll have to do. Yeah, that's a good clarification just to make sure. But yeah, if you're given the pounds, you're given the percentage, you got to multiply that together if they don't tell you the total amount. Okay, good question. Okay, so again, you didn't have to do it this way, but either way you came up with it, you should have come up with x equals 12. Okay, but whenever we have a word problem, we need to write it as a word answer. So I'm not going to just leave it as 12. I'm thinking 12 what? What did I just find there? 12 what? What's my label there?
Pounds.
Yeah, some of you are putting it in the chat. 12 pounds, and be more specific. 12 pounds of what? Of the deep thought, right? Like, be very specific what we need 12 pounds of. All right, and then, but I'm not done at that point, right? That tells me how many pounds of deep thought I need, but now I need to figure out how many pounds of oat dream. So using this, top equation there, that will make it easier. And I already have y by itself here in the red, and so I really can just put that in here. So I have y equals, and then I got negative x, so negative 12 plus 20, and so then y equals 8. Of this. And so 8 pounds of oat dream. All right, so those are my two answers. 8 pounds of oat dream, 12 pounds of deep thought. All right, questions on that?
I have one question.
Yeah.
About a story problem.
Mm-hmm.
I have hard time to recognize make an equation. So do you have any tip can help me, to make an equation? For the solving is okay for me, but when,
Yeah.
when
have
I
you
read
tried
the-
using the chart like this, like setting things up
No,
in a
I'm
table?
not. But I look at that kind of a lot better to me.
Yeah.
But some kind of different, different story. Maybe have to use the same chart like you said, or different.
Yeah, anytime you're mixing anything together, you can always use a chart like this if it's telling you to mix some things together. Or, there's some questions on the homework that are like, there's adults and children that went to like the county fair or something, figure out how many adults and children went. That kind of thing could be set up the same way as well. And so, but you just have to think about, like, what are your labels? What are things that are given to you here, right? Pounds and percent. But on some of them, like if it was, dealing with the county fair, it would be, well, instead here, it would be number of tickets and then the cost of the tickets. are kind of the things that we're looking at instead of pounds and percent. But same kind of way of setting it up. It's this next one that's a little bit different that we're going to talk about next.
That one, that's what I feel like the downstream and, like the
Yeah.
airplane. Yeah, that one I kind of sold my computer on that.
Yeah, let's take a look at this one too, because this is definitely, I wanted to make sure we kind of talked about another type, right, that you might see on there. Okay, so Cody's motorboat took 3 hours to make a trip downstream with 6-mile-an-hour current. The return trip against the same current took 5 hours, right? So the things we kind of need to know are these 3 things here. And notice that this is a 6-mile-per-hour current, right? That's not like how fast the boat is going. That's how fast the river's going that we're looking at on this. Okay, and so another thing, before we kind of start with this, let me just, clarify a few things. So we are given things about distance, rate, and time. So I know that I'm going to be using that distance equals rate times time formula. That's what's telling me I need to use that formula because I'm given those things in there. Okay, but the part that a lot of times people get a little bit messed up with is the rate. Okay, so I'm going to write over here about the rate. So when we're dealing with a boat, right, the rate